Hey everyone, and welcome to a new video. It's Federico here. It's been a long time since my last video, but today we are back with a little video. It's nothing too long or too complex. This was a question from a pattern of mine, and the question was how to draw something at the position of the mouse on the screen, and I'm drawing a little star at the position of the mouse, so you can see that when the mouse enters the window it transforms into this star, and when it exits we get our mouse cursor again. And this is something that you could use for your interactive installations, or if you want to make some user interface a bit more funny and interesting for your visuals application. Cool, so without any further ado, let's jump straight into it. So let's start from scratch, and first thing first, as always, we need our Jitter world. I'm going to make everything from scratch. I'm not going to use my snippet that I usually use. So we're going to call this main floating one, so the window will always stay on top. Then we say, I don't know, what do we need? The full scale anti-aliasing, and then we enable it by default. I think this is it. Let's maybe make the default size a bit smaller. So let's make it like that. Then let's create a GGL camera, which we will use to move around in the scene, which draws to main. And then we need to say, I don't know, position. Let's create an initial position 0.2, look at 0.00. And then we say lock look, so we'll always look at the center of the scene. And I guess this is it. Maybe we want to say also tripod one, so it will not tilt. Then let's use jitanim.drive to drive the movement of the camera with our keys, with our keyboard, and we can say UI listen 1. And then we create a message with written anim reset to reset the camera position. Right. Cool. So let's create a GGL grid shape in order to have a better sense of how the camera is moving in the scene. And it draws to main, and let's give it shape cube. So we have a big cube in our scene, but we can move around with WASD keys, WASD, Q, and Z keys, and to move around in the scene. Cool. Let's attach GGL PBR to it. So GGL PBR, not pics, but PBR. So it will have some shading with the light. At the moment there is no light, so let's actually create a GGL environment map, to which we will pass an environment map, like just a texture. And the PBR will automatically interact with this environment map. Now, to see this environment map, we can create a GGL skybox, which will then, oops, no, I don't even need actually to connect it. So cool. Now we have our object immersed in this scene, right? Okay, cool. So now we want to have our mouse transforming into some kind of pointer, some kind of cursor when the mouse enters the rendering window. Okay, cool. So let's do like this. Let's create a GGL grid shape, which draws to main, and let's give it shape. Let's make it just a plane, and let's make it white. So color white, right? By default is now at position 0.00, so it's included in the cube. It's like inside the cube, so we cannot really see it. So let's do like this, and let's set the position of this grid shape with our mouse position, right? So first of all, we need to get the position of the mouse, and we can get this from the Jitter world. So with the send window message, and then we say mouse idle 1. This should give us the position. No, it's I always mess it up. It's not mouse idle, is idle mouse, the other way around. But the message that we get out is called mouse idle. So yeah, just to make a bit more stuff a bit more confusing. So cool. This is called mouse idle. So let's root now mouse idle, so that we can have the position of the mouse in screen coordinates. So the corner here on the top of the window will be the left corner, will be 0.0, and all the way down to the actual size of the window. Nice. So if we want now to pass this position as the position for this mesh, for this grid shape, we need to transform it into world coordinates. And there is actually, if we create a GGL sketch, the GGL sketch is actually a function that transforms the coordinates from screen space to world space, and we could also do the same by sending a send render message to JIT and then screen to world $1 $2, and this will do exactly the same. So if we now do here screen, if we route now here screen to world and connect this message here, we should see the screen coordinates, the world coordinates. Okay, great. But as I said, yeah, I kind of jumped ahead of myself, but I want to do that using a GGL sketch, and the reason for that will be clear in a while. So let's get rid of that. We don't need to route anymore here screen to world, but we need to route it out of this GGL sketch, so screen to world. So this GGL sketch has the same function as the render. It will give us the position of the mouse in world coordinates. Exactly. So first we have the screen coordinates, and then here we have the world coordinates. The zeta value we can actually ignore because we don't really need it. So now if we say here prepend position from the world coordinates attached to the mouse, okay, what's happening? It's happening that yes, indeed, the shape is kind of following the mouse. So it's following the mouse pretty well, and it's actually super cool. The problem with that is that if we turn the camera, you can see that the shape is turning as well with the camera. So that's not what we want. So that's not what we want, because we will like to have just a 2D pointer on top of the world that is always on top of everything and is always facing the camera, right? Just if it's like a 2D thing. So in order to do that, we need to do something like this. We need to create a JIT-GL node, and which throws to main, of course, our main world, and then as a name, let's call it ortho node. And I'm calling it ortho node because it needs to project, it needs to render the scene. What did I do? Okay, it needs to render the scene using an orthographical projection, not a perspective projection. So if we go here in our camera and check out the ortho attribute, you can see that by default is set to perspective. Now if you will set this to 2, orthographic non-lens angle, you will see that the world is basically getting rid of the depth. Now this doesn't work at all with the skybox, it doesn't really work for what we want to do, because we still want to have our normal world rendered, our scene rendered, but on top we just want to have this 2D layer with our pointer. So we cannot get this ortho2 attribute to the main camera. We actually want to create another camera which draws this time to ortho node, and to this camera we want to say ortho2. Now all the objects that are rendered inside the GGL node will all have a projection matrix that is actually orthographic, so it doesn't take depth and the zeta axis into account. Cool. So if we now render this GGL grid shape, not anymore using the main world with the main camera, but we render it inside the node, it will use the projection matrix created by the other camera. So as you can see, this object is now only in 2D. The problem is that this GGL sketch that is getting the screen to world coordinates is not rendering inside our new world, it's still rendering inside the main world, so we have to fix that. So we just had to render that into ortho node, right? Okay, perfect. So now we have our 2D cursor on top of the main world. It's just too big, so let's make it smaller by scaling it to something like 0.05. Okay, perfect. So now, as you can see, we have our 2D cursor on top of our 3D world. Perfect. Now, if we want to change the appearance of our cursor, for example, using a sprite, an image, we can do just that. So let's create a JIT matrix, and let's say import movie, and then bang. So we import an image, and then we bang it inside a GGL texture. which also draws to orthonode, although this is not super necessary to specify where it draws, because I think it will anyway share the... Oh, what did I do? Yeah, right. Because I think it will anyway share the resources with all the rendering context in the scene and connect it to the GGL grid shape. Oh, one thing I forgot is that I would like to see the frame rate we're getting here. So I just connect a FPS GUI object here. This is called jit.fps GUI. Right, it tells us the frame rate we get from Jitter World. The frame rate is a bit variable because I'm recording, and so this kind of messes up with the graphic card, I think. Anyway, let's import an image. So I click here, import movie, bang, and then I go into my images folder, and I have here a collection of like little stars. I will just get one, and cool, we get our stars. Problem is, we would actually like to have that blending, so with using alpha blend and not having a black background. So let's go here and say blend enable 1. Let's see. Let's try again. I guess I also need to say depth enable 0. But if I set depth enable 0, now as you can see, my cursor is actually disappear, my pointer. And that's because we cannot be sure that it will always stay on top of the other objects. So what we can try to do is to set a layer to like layer 1000 or something, but this will still not assure us that the object will be on top of all the other objects from the main world. So what we actually can do is to use the capture attribute from node, which will now capture the scene to a texture, to a buffer, basically, and output it. And now we can render this scene to a GGL video plane. We can project it to a GGL video plane, which will draw to main with transform reset 2. So it will occupy the whole scene, right? And then we have it, our little cursor. But now we lost kind of the main scene. So what we need to do is to set here blend enable 1, depth enable 0, as we did for the grid shape for our cursor in order to get the transparency. And then again, we need to set the layer. So let's go here and set layer to a big value. And now, as you can see, it's overlapping on top of our cube, but the skybox is kind of always on top. So this is a sort of behavior which is not really what Max should do, I think. Now, what I think we want to do is to go into the skybox and set as a layer the value minus 1000. Cool. So now the skybox will always be behind every other object in the scene, even objects that use transform reset 2, like this video plane. Now the problem is that the video plane is just rendering at the moment the background color, which we get from the GGL node. So if we will set here the erase color to all zeros, okay, now we got it. So now we got the actual layer. Let's get back the star. We got the actual layer with the star on top of everything, and this will always be on top of everything. So here we actually don't need to blend, don't need the layer. Of course, if we want the texture again, I need to bang there. Cool. Let's actually make it slightly bigger, so 0.1. Right. Nice. Now the last touch is that I would like to have the mouse, the actual mouse pointer, disappear once we are inside the window and reappear once we are outside. So in order to do that, we can use here this message, which we get when the mouse goes out of the window, which is mouse idle out, which will give us the position of the mouse when it exits the window. And when this happens, we want to send a message to Max, the message hide cursor. Okay, this message will hide the cursor, but before we connect it, let's create also the counterpart, which is show cursor. In this way, we can say that when yeah, actually when the mouse is outside of the window will be shown, and when it's inside the window will be hidden. So what we want to do is to just trigger here a bang. We just want to send a bang basically every time the mouse is inside the window, and as you can see, the mouse pointer, the black pointer, is disappeared, and when we exit the window it will reappear. Let's trigger a bang here as well, just to be completely cool. Nice. There is one last thing, which is that when I press the left mouse button, the star will not move anymore, because when we press the mouse we get another message out of Jitter world, which is only mouse. It's not mouse idle, it's not mouse idle out, it's just mouse. So let's root here as well also mouse, and this we want to connect here, and this we want to connect now to screen to world. So now even if I click, the star will be always inside the will always be moving inside the window. Cool. And I guess this is going to be it. Of course, we could apply also video effects to the mouse thing, because now this is just a texture, right? And we could create our own UI that is just 2D and is always on top of everything. So for example, we could create another grid shape, position it somewhere, -1, 0.8 or something. Position, if I could just write. Right, so this would be like a little UI that is always on top. Okay, yeah, then we should do some blending things to get it in a way that the cursor is not actually overlapping with this other UI element. For example, could be that we need to say here blend enable, actually depth enable 0, and then give it a layer that is always on top of the other element in the UI. So yeah, something like that. Cool. But let's stop here before we introduce too many elements, and thank you very much for following as always. If you prefer to just download the patch without recreating it from watching the video, you can get it from my Patreon channel and join the Patreon community, which at the moment is more than 400 people. And thanks again for following. I will see you in the next video with more Jitter Max stuff. Have fun. See you soon.